So we're on to now revising sketching quadratics and solving them. So kind of identifying all these different properties of a quadratic function, the roots, the axis of symmetry, the coordinates and nature of the turning point, and the y-intercept, and finding out all those individual little bits and then actually sketching the graph of the function. Okay, so that's what we're on to just now. So example 6, can you copy down the function f of x equals x squared minus 2x minus 24? And what we need to do is very methodically find each kind of one of these properties: roots, axis of symmetry, coordinates, the nature of turning point, and y-intercept, and then put it all into a graph. So roots is the first thing to find. Now, the roots, as we hopefully know, is the solution to the quadratic. It's finding out the 2 points where the graph cuts the x-axis. That's what we've been doing over the last week or so with our quadratic formula. And before that, solving quadratics through factorising. Now, when we are asked to sketch a graph and we're asked to find the roots, we will never have to use the quadratic formula for this to find the roots. We will always be given a quadratic which we can factorise. So the roots are always going to be found through solving by factorising. So maybe worth putting that little note there. So roots solve by factorising. Okay, so we've got, remember, we can either solve by factorising or solve using quadratic formula. But when we're sketching a graph, we should always be able to factorise this. So x squared minus 20 minus 2x minus 24. Now, the roots occur when y equals 0. So we change f of x to 0, and that's what we set this up to equal 0. So x squared minus 2x minus 24 equals 0. Now, factorising skills, I'm not going to go through the full factorising method. You need to factorise this in any way you can. ABC method, St Andrews cross method, right? I do this just through, you can do it just through observation. So if it's an x, 1x squared, it's x and x. Now the two numbers here need to multiply to give me minus 24 and need to add to give minus 2. So I'm going through the options in my head, 2 and minus 12, something like that. That's too big of a difference. It doesn't have a difference of 2 when you add them. But 6 and 4, right? I've got 6 and 4 in my head, and I know that they multiply to give me 24, and I know that they have a difference of 2. So I should be able to make one of them positive, one of them negative, to give me a multiplication answer of minus 24 and an addition answer of minus 2. So let's just think about it. If I had minus 4 times positive 6, that would be minus 24. But minus 4 add 6 is positive 2, not minus 2. So it has to be the other way about. So if it is minus 6 times positive 4, they multiply to give me minus 24 and they add to give me minus 2. So that's my two solution. That's my two brackets. And my two roots come from bringing these two brackets down. So x minus 6 equals 0, so x equals 6. X plus 4 equals 0, so x equals minus 4. So my two roots are at x equals 6 and x equals minus 4. So I've already got a kind of set of axes in my head, and I'm marking on that I'm going to have one root kind of along the x-axis at positive 6 and one at minus 4. Okay, that's the roots. Next thing is to do it's probably easiest to do the turning point. Now, the turning point, when we have our quadratic in this function, is always the midpoint of both the roots. Okay, we'll go on to completing the square later, where that is, when we had our quadratic y equals x plus 1 squared minus 4, we said, the turning point was then minus 1 minus 4. Well, I don't have my quadratic in this form up here, right? That's called completed square form. I don't have it in that form yet. I can find that later on, but right now I've just got the roots and I've just got the trinomial like that. So midpoint of the roots is going to be my turning point. So maybe mark that one. So midpoint of roots. That's going to get me the x value for the turning point. So the x value for my turning point is going to be -4 plus 6 divided by 2. So literally find the average of the two numbers. Add them together, divide by 2. That's going to get you what's right in the middle. That's just the mean of the two numbers. So the x value is -4 add 6 is 2 divided by 2. That's 1. So the x value of the turning point is 1. When x equals 1, y equals, and all I have to do is substitute my value of 1 in for x. So go back to your original f of x. So that's going to be 1 squared minus 2 times 1 minus 24. So that is 1 times 1 is 1, minus 2 times 1 is minus 2, minus 24. So 1 minus 2 is minus 1, minus 1 minus 24 is minus 25. So that turning point is therefore 1 minus 25. Okay, right, what else do we need to find? Well, we need to find the axis of symmetry. I could maybe do that in this little gap here, axis of symmetry. Now, I did the turning point first because when we have the turning point, we can very quickly state the axis of symmetry. Remember, it is x equals the x value of the turning point. So we already know from up here the x value of the turning point is 1. So the axis of symmetry is a vertical line, x equals 1. And the y-intercept is what I can find up here. Now the y-intercept you can mark on, just to remind yourself, you always set x equal to 0. Okay, because the y-intercept is the point where the graph cuts the y-axis. At the y-axis, the x value is 0. So you take, basically rather than, you take f of x equals x squared minus 2x minus 24. That's just the starting thing from the question. And we're going to set x equal to 0. So f of 0. So 0 squared minus 2 times 0 minus 24. So that is just 0, take away 0, take away 24. So it's just minus 24. So y-intercept is going to be 0 minus 24. Okay, so I have all these individual parts, individual features of my quadratic. What I need to do now is to make a sketch and mark these on. Okay, so there is kind of a lot of stuff going on here, so you need to try and lay it out in a kind of clear, methodical way if you can. I know my turning point is minus 25, so I'm going to leave a lot of space kind of down at the bottom underneath my x-axis. So that's x, that's y. So order of things. So first thing is we're going to mark on the roots. So remember, the roots are the points on the x-axis where the graph is going to cut. So that is going to be x equals 6. So just doesn't need to be, you know, proportionally, but you just need to mark on the numbers. So x equals 6 and 4. So you can mark on those, minus 4, you can mark on those 2 points. We have our turning point, which is positive 1 minus 25. So that's going to be like a way down here, and you need to mark on that coordinate point. We have our axis of symmetry, which is going to be a vertical line, dotted line. We'll get to that in a second. And we've got a y-intercept at 0 minus 24. So that's on the y-axis, and that's just ever so slightly higher than the turning point. Now it is an x squared graph, therefore it is, the nature is a minimum turning point. So what we should have probably said in the turning point is this is a minimum. It's a happy face parabola, meaning there's a minimum turning point, which just means we've got a kind of happy face shape. So if you are able to draw that set of axes, you've marked on your roots, your turning point, your y-intercept, you should now be able to just connect those with a happy face, smooth parabola. Okay, and that is the graph of f of x equals x squared minus 2x minus 24. Okay, so you guys that are here, hopefully you managed to get all that down.